the get-go. Okay, here's the deal. For 99.4% of what we have done in trig here, we've been looking at right triangles, right? But in some instances, triangles are not right triangles, and we still need to be able to solve for information in those triangles as well. So we need some idea of how to find angle measures and lengths of sides if we are given a triangle that is not a right triangle. And so that's where the law of sines and law of cosines comes in. We've got formulas. I've got formulas written out for the law of sines here. We've got law of cosines on the next page. Calculators. Sorry, let me. So yeah, please make sure your calculators are in degrees in both document settings and in the scratch pad, right? Okay, so for the law, in order to be able to use the law of sines, what I want you to notice is that more often than not, you are going to be given more angles than you are sides. In some other instances, you can still use the law of sines. I'm going to show you visually what that looks like. So it's not a definite always, but I will tell you that if you are given an angle-angle-side relationship, if you are given an angle-side-angle relationship, you can use the law of sines. Like I said, there are other instances where you can also use the law of sines, and I'll kind of try to point that out to you, okay? What I want you to notice about how we use these formulas, we're going to look at this as a proportion, so we'll use two of these together at one time in order to set up our proportion, and then we can cross multiply and solve, okay? We're given information about A, B, and C. It does not matter where you put A and B and C for the angles. It does matter where you put the sides in relation to those angles. So remember, if we say that this is angle A, then this is side A. If this is angle B, then this is side B. And if this is angle C, then that is side C. So the side is always opposite that angle measure. Okay? All right, so let's label what we've got, and then I want you to notice we are given more angles than we are sides. So we're told that angle A is 40 degrees, we're told angle B is 60 degrees, and we're told that this side is 20. So guys, visually, this is what we want. If we have an angle measure and then the side opposite that angle, we can use the law of sines. Okay? We don't have set directions here. Sometimes you're just asked for another angle measure or another side. If not, then it's pretty much understood that you're going to solve for the whole rest of the triangle, whatever is missing. Okay? All right, so it's very easy to figure out what angle C is because all of the sums of the angles have to equal how much? 180. So if we do 180 minus that sum of 100, we know that angle C has to be equal to 80 degrees. So we can label that right away. All right, and so now we've got to figure out what side B is equal to, and we've got to figure out what side C is equal to. We're going to use these formulas. So we're going to kind of set up the proportion here. So we can say that the sine of A, sine of angle A, which is 40, is to side A, which is 20. And that's going to be equal to, let's set up both of them. So we get the sine of 60, which is angle B, over side B. And we're going to go ahead and set up this other one also. So sine of 40, that's angle A, is to side A, which is 20, over the sine of 80, all over side C. All right, so let's think about how we can solve from here, right? We've got proportions that we've set up. So we're going to cross multiply to solve. So we get that B times the sine of 40 is equal to 20 times the sine of 60. And so then to solve for side B, we're just going to have to divide by this sine of 40. So 20 times the sine of 60 all over the sine of 40 to get side B. Katie, Rachel, Ryan, Reed, will you guys plug in and see what you get for that? Compare answers. For C, we're going to cross multiply here. We get C times the sine of 40 is equal to 20 times the sine of 80. And then we've got to divide by this sine 40, so okay. Is that what you all got? Katie, Rachel, Ryan? 20.
What decimal should I round to?
Yeah, we'll go to probably 2 places after the decimal. It'll tell you specifically. Most of the time, I think, like on the worksheet that you're going to do, the homework problems that you're going to do, we're going to round to the nearest degree and then tenths for the side. Airily. We've got to divide by that. So you've got to do 20 times the sine of 80 all divided by the sine of 40. You can't do any dividing out beforehand. You've got to keep it as it is. Okay, so from this step? Yeah. Okay, from this step, I'm trying to get the C by itself. So I'm dividing by this. Do you see that? Yeah. Is that what you were asking? Okay. Peyton, Solomon, Christian, Jackson, can you all plug in and check and see? Let's compare answer. What do we get for C? 30.66? Okay. Oops. That's right in a different color here. 30.64. Okay. We don't have units given there, so we'll just keep those answers as is. If you're given units, obviously you want to include those. Okay. Did we get that, Peyton?
Can you just on one of them, do like a squared, b squared, c squared?
But we don't have a right triangle, so no, we can't do that. Yeah, good question. I'm glad you asked that. We don't. If we had right triangle, we could use Pythagorean theorem, but this is not a right triangle, so we cannot use Pythagorean theorem. Okay? All right, let's look at this other example. I kind of drew in the picture already. I hope you like my artistic abilities there. It's about as good as it gets. 2 forest rangers 10 miles apart from each other on a straight service road sight a fire. They determine that the fire is between them. The first ranger's line of sight to the fire makes a 34-degree angle. And the second ranger's line of sight makes a 67-degree angle. How far is the fire from each ranger? So we are looking for this distance and that distance there. All right, so we've got to figure out angle measure first, right? How can we figure out that angle?
79.
It is 79. What'd you do, Reed?
I added 67 and 34 and subtracted 180.
There you go. So 180 minus 67 minus 34, that gives us 79 for that angle, that missing angle up there by the fire. And so let's set up our ratios. Let's set up our proportion, excuse me. So we want to say that the sine of 79 is to 10 as the sine of 34 is to y. And then we'll say that the sine of 79 is to 10 as the sine of 67 is to x. All right, then we've got to cross multiply. So we get y times the sine of 79 equals 10 There's that one, and then x times the sine of 79 equals 10 sine 67. All right, try that. Plug those into your calculator. We'll go over answers in a second. All right, so yeah, so 5.7 miles if we round that, and then 9.4 miles. Did you all get those? Hold on just a second. I've got to send Christian, and then I will send you. All right. I have posted these notes already online. The other thing to notice is, are you given more angles than you are sides, typically? Okay. So if you feel like you want or need to look at all of the examples, they will be online, but we're not going to go over example 3. I do want to talk to you about example 4, though, because if you notice, this one's a little bit different. I need you to notice you're given more information than you were on these others. We're given, this is actually angle measure, and then we have the side opposite. So that's how and why we can use the law of sines, because then we're just given all 3 sides. But because we are given the angle and we are given that side opposite, we can still use the law of sines on this. So that's nice, okay? All right, so we can say that the sine of 88 is to 26 as the sine of angle B is to 16.1. So that's the one proportion set up. The second one, take a look. We're gonna have to do the sine of 88 is to 26 as the sine of C is to 21. So guys, there's a little more work involved on this one because we've got to do, in this case, the sine of B is going to be equal to 16.1 times the sine of 88 all over 26. So we get long decimal for that. I'll ask you what that is in just a second. And then we've got to do inverse sine to find the angle measure. And then similarly here. Now, at this point, you could actually also just subtract from 180, but it's actually kind of nice to do this as a check. Okay, so check to see, like, do all of the multiplication, let's get what that decimal is, and then let's actually solve for the angle measures.
Do you want us to round to the nearest degree?
Yeah, let's round to, yeah. Oh, you know what? We just have to find C. Look at that. I'm trying to do all of this extra work. Look at me. We don't have to worry about B, do we? Let's just focus our attention on that one. Sorry about that, guys. I'm just getting too excited and doing too much. That's okay. All right, so 21 times the sine of 88 divided by 26. What's the long decimal that we get for that? Sine of C is equal to 0.807 long decimal. Lots more numbers. Okay, then remember to find an angle measure, you're doing inverse sine. So that's the sine to the -1. So inverse sine of that answer equals, so what do we get for C? And yeah, let's round to the nearest degree.
54.
Okay, I think it ends up being 53.8.
Yeah.
So let's round it to 54 degrees. Okay? All right, Christian, go quickly. Try to get there, yeah. All right, that's law of sines. So think visually, remember, if you have angle measure and you have side opposite that angle, that's what you're looking for to be able to use the law of sines, okay? Otherwise, all right. The law of cosines tends to be used. I need you to notice if we have more sides given than angles, then we're going to have to use the law of cosines first. The good news is that once we've used the law of cosines once, then we can move to the law of sines typically, okay? Notice, I put a little note here. It says, think of this formula as the Pythagorean theorem with a bit of an adjustment. So if you look, this is a squared plus b squared equals c squared, but then there's this little adjustment here at the end. And that's what we have to kind of deal with mathematically, is think about how that affects things, okay? So I want you to notice also, if we're given an angle measure, that helps us figure out which form of the equation we're going to use. If we're given angle A, then side A is going to be in the formula by itself over there, and the B's and C's are what's here together. If you're given angle B, there's the relationship with the B's, and then that means A and C are together here. And then if you're given angle C, then the A and the B is together, and you have the C here and here, okay? All right, so we'll look at a couple of these examples as well. Keep in mind what I said earlier. It doesn't matter when you draw your triangle where you put angle A. Just make sure that you're putting side A opposite angle A and side B opposite angle B and so on. Okay, so this is what we are given for that first example. So because we are given angle A, we're going to use that top form of the formula. So it says a squared equals b squared plus c squared minus 2bc times the cosine of angle A. So then we're just trying to plug in what we can, right? So we get that a squared is equal to 16 squared plus 19 squared. 16 and 19 get plugged back in, and then times the cosine of 35. Here's just going to your calculator and plugging in carefully. So plug that in and get what a squared is equal to. And then make sure you remember to square root that to get your actual A. So try that and see that you get that. Plug that in and check and see that you get that for side A. The beauty of the law of sines is that now, yeah, we've had to do that pain in the neck work for the law of cosines here, but now we have angle measure and we have side opposite that, so we can go to the law of sines now. It's not ideal because we've rounded this answer, but it's all we've got, so that's what we have to go with, right? So now we can figure out, we can say sine of 35 is to 10.9 as the sine of C is to 19. And we can also do sine of 35 is to 10.9 is sine of B over 16.
Do we need to do, like if we were doing something like equation, like would we need to do the sine C and sine B, or can we just do one?
Can do one and then subtract from 180. So good question. Yeah, I was going to mention that. Like I like to plug in just to kind of check myself.
Yeah.
But yes, and here's the deal. In some ways, it's actually better to do what you're suggesting, Reed, and subtract from the 180, because what happens is your answers, you end up kind of rounding some things, and then stuff falls, There's rounding issues.
Yeah.
So the answers are not quite exact. Okay, Katie, go quickly. All right, so what do we get here? Let's see. If we plug in, we should get that C is 88.859 and B is 57.352. Okay, as soon as she gets back. Okay, I'm gonna do, let's do number 2 and then we're gonna jump to number 4. Number 4, the work is a little bit different than these others. So these first few are, if you're given an angle measure, it's pretty, in my opinion, it's a little bit more straightforward. It's still pretty involved, but okay, I'm seeing that we have angle C given. So I'm going to plug into the form of the equation where the C is by itself on the left-hand side. Minus
We
2.
have these formulas.
Yes, I will give you these formulas. So once again, we're just kind of plugging in here. So C is equal to 15 squared plus 18 squared times cosine 36. So when you plug all of that into your calculator, do be careful with that. It's easy to kind of make careless mistakes with the plugging in on the calculator, so do be careful with that, okay? On this one, we get that C squared is 112 point whatever, so we get that C is 10.59. And now we have angle and we have side opposite that angle, so we can go to our law of sines. So we would set up sine of 36 is to 10.59 as sine of A is to 15. Cross multiply. Sine A, you've got to do inverse sine of all of that long decimal to get what your angle measure is. So you get that A is 56 degrees. And then if you use Reed's idea of just subtracting from 180, you get that angle B should be 88 degrees. Okay. I went through that one quicker just because you've kind of seen that process. All right, I need to... Hold on, you've got to see this. So you wait. All right, once again, if you feel like you want or need to see another example of that first type, I will have that here. This one is very different because if you notice, you are given side, side, side. So pick an angle measure, A, B, or C. Christian. No.
Oh, so
A. Let's go with A. All right. So if we're using A as angle A, then that means the form of this that we are going to use is little a squared equals little b squared plus little c squared minus 2 times little b times little c times the cosine of big A. So let's plug in what we're given. So notice we're just given sides. So we are given this on the left-hand side. Guys, people tend to make really careless math mistakes at this point, and that's what I want you to try to avoid, okay? this is getting multiplied times that cosine of A. This stuff is getting added. So we need to deal with those kind of in two separate steps, okay? I want to move this over to the other side. So we want to do 11 squared minus 13 squared minus 15 squared equals, and then we got to figure out what that negative 2 times 13 times 15 is equal to. Okay, so this is two important separate entities. The tendency is to want to try to combine that negative 2 and the 13 and the 15 with those squared values, and that will totally mess up all of your math, because that 13 squared and 15 squared are not getting multiplied by that cosine of A. Okay? So Airly and Reed and Jackson, do me a favor, and the 11 squared minus 13 squared minus 15 squared, figure out what that's equal to, compare answers, make sure you all have the same thing. Christian, Solomon, Peyton, will you all work on the negative 2 times 13 times 15 and compare answers to make sure we get the same thing?
I'm working with that. Negative 273.
Okay, so the 11 squared minus 13 squared minus 15 squared gives us what? Negative
273.
273. Okay, equals, okay, and that multiplied together gave us what?
Negative 390.
Negative 390. Okay. So we have negative 273 equals negative 390 times the cosine of A. So now we've got to divide both sides by that negative 390. Okay, so we're going to have cosine of A is equal to some number. What do we get for that? 0.7. Nice. Okay, so A is equal to 46 degrees when you do the inverse cosine to find that. So that gives us 46 here.
Is that 0.7 equals cosine?
0.7, yeah. The negative 273 divided by negative 390 gave us that. Please, please, please be careful with this at this step, guys. It's just so important. And it's so easy to try to combine all of that together, and it's not correct mathematically. All right, so from here, we can set up law of sines, right? We can say sine of 46 is to 11 as sine of B is to 13. So sine of B is equal to 13 times the sine of 46 all over 11. You get long decimal, you're going to do inverse sine, and you get that angle B is equal to 88 degrees. And then from there you can subtract from 180, and you should get that angle C is equal to what? Let's see, 76 degrees. If you've done the work, once you've gone through, okay? All right, questions?
Is it 46 or 76?
A is 46, B is 88, and then you get that C, I think, hopefully. A is 46, B is 58. Yeah, somebody do the math for me there.
Yeah, because I got for C, I did C to B, and I got like 79.
Okay, we're going with B first. So I was looking at the wrong page because I handed something to Ryan, so I got lost here with which page I was looking at.
Does it matter which one you did if you heard it with your C at the end?
No, it doesn't, but I've got this written out, so I want to go with that. And I apologize because I was looking at the wrong thing. So guys, what is this equal to? Sine of B, what's 13 times sine 46, all divided by 11? I need that decimal.
0.8501.
0.8501, more stuff. Then we get angle B, which is equal to 58. Okay, 58 degrees. And then we're going to subtract from 180 to get C. Yowza, sorry about that. C, what do we get? 76. Okay. Awesome. Okay, it does not matter, Katie, you were asking, it doesn't matter if, once you've found angle A, if you go find angle B first or C first, that's not gonna matter. Okay, good question. All right, your classwork and then homework is to finish is the next 3 pages. It's pages 5 and 6 and 7. So you've got time to work on that now. Ask questions of me. I'm gonna pull out the answer key so you can kind of check along the way, make sure you're doing okay. I need you to notice, you're gonna have to look at the problem and figure out, can I use law of sines or do I have to go law of cosines or what? So that's part of what you have to figure out, okay?